Hello everyone. So moving forward with our lesson, we want to find the area of a regular hexagon and the side lengths of 8. So since it's a regular hexagon, that means all the sides must be the same. So I can mark that appropriately. And that also means all the angles are the same. So each interior angle must be the same. Now, how can we solve this problem? Well, let's use the trick we used, or not trick, the technique we've always been using, which is try to make simpler shapes out of this complex shape. Well, if I start connecting some of the diagonals with each other, which is always a good strategy, we can see that this hexagon is broken down into different triangles. So if we can determine the area of these triangles, we can determine the area of the entire shape. Now, what can we figure out about these triangles? Well, we have that one of the side lengths is 8, but I need the other side lengths, or I need a height at least, to solve this problem. Now, how can I find the height? Well, we don't have any other side lengths to go off of besides the 8, which means I should check if there's anything special about the angles in the triangle to help me out. So, I know that each angle of this hexagon is equivalent to the number of sides, 1, 2, 3, 4, 5, 6 sides, minus 2 times 180, and then divided by the number of sides again, 6. This is what we covered the last lesson. And if we can simplify that, we'll find the measure of each angle in the hexagon. So, I know that, well, 6 minus 2 is 4. And I can even simplify that further. 4 over 6 is the same thing as 2 over 3. And continuing further, 180 divided by 3 is the same thing as 60. So we have 60 times 2, which is 120 degrees. So each angle in the hexagon is 120 degrees. Now how can I use that to solve the problem? Well, if this angle is 120 degrees, then this angle on the inside must be 60 degrees since it's being cut in half. And this angle is also 120 degrees, which means this angle right here is 60 degrees. And that means that this angle on the inside has to be 60 degrees as well, which means it's an equilateral triangle. And in fact, you'll find that all of these triangles must be equilateral. So, how can we continue from there? Well, if we know they're all equilateral, we know the side lengths are the same. So each side length is 8. And therefore, I can just use one of the formulas that we used for the area of an equilateral triangle. So the area, this is for the equilateral triangle, or else I'll just put a T area of the triangle. Now there's a special formula we learned about where we found the area of an equilateral triangle, and we know that that is the length of the side squared. So like we could say that that's like x squared is the length of the side times the square root of 3 over 4. Now if you do not remember this formula, that's fine. It's when we did 30, 60, 90 triangles on the first time. Just keep in mind this is a formula we will be using for at least this problem and the next, and a lot of hexagon problems involve this. So we know that the side length is 8, so that would be 8 squared times the square root of 3 divided by 4. Well, 8 squared is 8 times 8. We have the square root of 3 over 4, and 8 over 4 cancels out to just 2, so it's really just 2 times 8, which is 16 square root of 3. So the area of the hexagon in this case, which I'll label A sub h, well, we have 6 triangles in the problem, so it would be 6 times the area of the triangle, which we know is 16 times the square root of 3. And 6 times 16, well, 6 times 10 is 60, 6 times 6 is 36, 36 and 60 becomes 96, and then we have our square root of 3. And that becomes our answer. So again, breaking down this problem into simpler parts definitely helps us a lot. Now, let's say you didn't remember the formula for the area of an equilateral triangle. You could have drawn the height and used Pythagorean theorem to find the length of the height by saying that this is 8 and this side would be 4, and doing all that and use the regular formula and gotten the same answer. But it's always good to remember past things we have learned, because it can make our life easier doing future problems. And always keep in mind, regular hexagon always implies equilateral triangles. This is a very common thing that we see. In fact, it's in a SAT question that I've covered previously for like other classes and stuff. It's something that's useful to know.